in a town called Wickenburg, outside of Phoenix, just about 70 miles northwest.
Oh, nice.
The weather's nice anyway, I can tell you that. I was just back in Boston last week, and still not quite spring there yet.
Hey, Matt, it's Jim O'Connor. Well, we got a minute. Great to see you. I'll look forward to coming back to K-Joy and another deal for you guys when we come back down to LA and getting into the RF. I was thinking about having my friend Howard Fine do a presentation for y'all, and we got new goodies for the tour this year. So really looking forward to it. And also want everybody to know that I've joined the board of Veterans TV, and we are aligned towards looking for active duty military looking to transition civilian quarter and wish to work in our field. So if you guys know of anybody, we can provide training. We have a fully equipped truck up in Grass Valley, and of course my organization has it as well. So there you go, man. I just thought I'd throw it out there, and thanks for proud to be a member of Los Angeles chapter 47 after moving out here. Although I'll be back on the road, you'll see me on these remotely. So thank you.
Yeah, no, good to see you, Jim. Thanks for being here.
Thank you, sir.
All right. Wait a few more minutes. And Paul, one thing we do too is we record the meetings, as you probably just saw, and we put them on our Facebook Live for people to watch later, just so you know.
Cool. I believe some people from Chapter 9 are going to join as well.
I believe so, yeah. Oh, Dick has no audio. All right, I see it. I see it, Dick. Chapter chair news. Okay, I think we'll start here in a few minutes. Looks like we got a few people from the 3 chapters. Okay. Well, I say we get going, and all right, Dick, I'll call you later to figure out the no audio issue. All right, so we'll get going. We do our chapter business first, and then after that, we'll get right into the presentation, Paul. So SBE47, this is our April meeting. So thanks for being here. It's our evening meeting. Last night, we had our board meeting, which we always typically have the Monday before. A couple things we talked about is the chapter. As a board, we donated $500 to the Mount Wilson Observatory to pay for a water pump that they use to pump from a well, I guess, for, during wildfire season and stuff. So we partnered with the SCFCC, basically went in with $1,000 donation, 500 from each group. And the intent was kind of to encourage others to maybe, help out. And it was really successful. I was really happy how that all went. Other TV stations, radio stations, and even ATC, they basically all donated to the group. And I think they even exceeded their goal a little bit. So that's great. It's great as a group. I kind of see our group as a partnership organization, try to keep good relationships with people. And Mount Wilson Observatory definitely does a lot
Matt,
for
can
us.
you hear me?
I got you, Dick. Can you hear me?
Raise your hand if you can hear me. I have no audio.
Okay.
I have no audio on this.
Let me just chat here and say, I'll call you in a few, Dick. Okay. So we were really happy as a chapter how that worked out. So that was main thing last month. Let's see, the NWS Weather Service NPT that came out as an RMT, that went well. That was last month. No real issues I know about, at least for this market. We're looking into possibly going back to in-person meetings in June. So we're looking into that. Kind of looking at local guidelines and mainly trying to figure out who will, host us. So we got a few ideas for that we're looking into. We also, our YouTube page, 3 of us met a couple weeks ago, I guess a month ago now, and did some filming for CRO type videos. That's the certified radio operator exam. So the intent was that we'd film these kind of basic videos that people could watch or students could watch. Jason on our board, he teaches at Valley College, so he shows the videos, and we're proud of them. We think they're kind of cool. So if you go to YouTube, make sure you subscribe to our YouTube channel, check it out. If you have any comments, let me know, or you want to be a part of the video, help out, let me know as well. So that's another cool thing that we've been doing. This month we have Paul Schulings that will present in a few minutes. So we're excited to have you here, Paul. Thanks for taking the time. One other thing is that we have a new chapter member, Allison Cox of Mr. Master AIM. Do a lot of barter spot verification, stuff like that. I'm sure most people know who AIM and Mr. Master are. She's now one of our SBE chapter members. So she couldn't make it tonight. I know she wanted to, but just wanted to say welcome Allison to the group, and happy to have her as a member. Going through other national SBE stuff, April 23rd, SBE National will be meeting at the NAB. So make sure you check that out. That's that Monday. Webinars coming up. If you're a member plus, you can, be part of all these webinars. It's definitely worth it. If you do one webinar, it's definitely worth to have the plus. Deadline to renew your membership, April 1st. Well, that's already passed, but I know they're still doing a membership drive that continues through May 31st. And if you help someone sign up, I know that kind of you get thrown into a raffle, I believe, yourself. So membership drive going on, becoming SBE certified. They have the June date. Doug Irwin is our program, he's our program chair, but also our certification chair. So if you have any questions about testing or anything, make sure to reach out to him. And compensation survey is going on if you want to be a part of that. I know that comes out, I guess it's going through May 16th, and then the results come out. And then the 2022 leadership development course is set for August. All right, that's what we got for now. Anyone from San Diego, chapter 36, have any thing you want to share? Okay, chapter 9, Arizona. No new business. Okay, David, got it. Anyone else want to talk about anything else in local market, radio, TV, anything to bring up to the group? All right. Well, without further ado, Paul, let you introduce yourself. Thanks for being here, and excited to see the presentation.
Okay. Well, thanks a lot, Marcos. I appreciate that. And I'm delighted to be here. And thank you, Matt. And I see some familiar faces out there. Richard Silvera, haven't talked to you in a while. Great to see you. I appreciate the invitation, chapter 47, chapter 9, and chapter 36. Thanks very much. Let me see if I can share my screen here, and we'll get into the presentation. Bear with me one moment. Okay, is that good? Everybody see the title screen on there?
Yep, got it.
Okay, great. Thank you. So for those of you who don't know me, my name is Paul Schulins. Been in the broadcasting business for a while now, I guess close to 40 years or so. Spent most of my career in Boston with Greater Media as a director of engineering for the local cluster of FM stations there. Recently, I had moved out of that position and worked for the remote control folks up at Burke Technology in Massachusetts, where I served as their CTO for about a year and a half or so, and then decided to go out on my own, do my own thing, and wanted to tell you a little bit about what I am up to. I started my company called Shulin Solutions, which is really got three pillars. It comprises a RF monitoring system that I've installed about 70 of these across the country for mostly American Tower. Not too many out here in the West. I did some Seattle locations and let's see, yeah, Chicago, and most of them were Midwest and East Coast. But the RF monitoring system called Stellar Eclipse is basically a monitoring and VSWR protection system that is mostly used on TV, UHF, VHF, and FM on combined systems to interlock transmitters, and to also provide the tower owners and the tenants with real-time information in terms of what's going on right now and historical stuff. The other pillar is SUAS and drone inspections. And I specialize in two areas here where I'm doing visual drone inspections as well as infrared, which is what the presentation this evening is all about. And the third pillar is just general broadcast consulting for designing studios, transmission sites, and that kind of thing. And this is a little more information about the Stellar Eclipse product. I'm going to be actually at NAB, so if anybody wants to have more information, I've got my website up, but I'd also be happy to meet with you at the show if you're attending. So let's get to the meat of the presentation. It runs about an hour here, and I'll probably pause in the middle for some questions and certainly have some time at the end for questions and answers. But I'm pretty excited about this. I'm a private pilot, so I'm excited about drone operations, especially where we can use them to benefit broadcast engineering, as well as photography. I'm into astrophotography as well. So infrared photography wasn't too much of a stretch from that. In fact, there are a lot of parallels between the kind of software that you use for imaging deep sky objects like galaxies and nebula, as well as bringing out the details for infrared photos. So let's begin with a little bit of history about infrared radiation and how it came about to be discovered. You might have heard of William Herschel. He was a famous astronomer born in the 1700s. And he used, at the beginning, sunlight in a prism, and he observed the different colors. But he was really the first person in the modern age to discover that different temperatures equated to different colors. And he also noticed that red light was the warmest. And even beyond that visual range, he noticed that the temperatures got warmer right after what he could see in the red light. He also discovered the planet Uranus. He used a visual telescope like the one in this picture to discover that planet. And he was also doing early experiments with spectrometry late in the 19th century. So he was breaking apart those different colors that come from the different objects in space and determining what kind of materials were present on those stars. Pretty amazing stuff for that time period. So what is infrared? Well, infrared radiation is classified as light that's generally invisible to the human eye, about 700 nanometers and longer. It's there's no hard limits to what's actually visible to the human eye, as the sensitivity does drop off very, very quickly at about 700 nanometers. And sources longer than that can still be seen if they're sufficiently bright, but the problem there is there's also sufficient heating to cause some damage to eye tissue. So not a good idea to look at infrared radiation for very long, because even though you can't see it, it can be damaging to human tissue. So I've been learning a lot about infrared over the past 3 or 4 years. In fact, there are actual certifications for infrared photography and understanding infrared. And there are 3 levels of certification for thermography. I just completed level 2. And it's mostly math and theory about what infrared is and how to properly interpret infrared images. So a lot of people that are working in power plants, doing surveys of solar arrays, doing roof surveys, doing windmill surveys, all those kind of folks are very interested in understanding how infrared works and what the theory is behind it. And one of the major concepts they talk about there is the concept of emissivity. And that's very significant to understanding heating as it applies to transmission lines and antennas. And the definition of emissivity is a measure of how efficiently an object radiates heat. In other words, how well it really tells the truth about its temperature. And the emissivity values range from 0, which is like a perfect mirror that reflects all energy, to 1, which is a black body that absorbs and radiates all the energy that is falling upon it. So in general, if the emissivity is very low, below a 0.5, you're unlikely to get an accurate temperature measurement with any kind of camera. And in these cases, you may need to find ways to artificially increase the emissivity. And one of those ways is putting a piece of known emissivity material on top of what you're measuring. And there are other ways to do it theoretically, but in the case of measuring transmission lines, I know the emissivity of black electrical tape is 0.95, which is very high. And what I'll do in many cases is put a piece of tape on that line, and I'm able to measure the temperature very accurately at different points without having to tape up the whole line, because you can get that reference measurement from the piece of electric tape. And I'll demonstrate that in this slide here. You see a couple of cans on the left. That's a visual picture. You see the electric tape on the cans. And on the right, you see an infrared picture of those 2 cans as well. And you can see that the temperature differences between where the electric tape is and where the shiny metal tape is very, very dramatic. The spot temperature of where the yellow tape is appearing in the infrared picture shows 163 degrees Fahrenheit. And just a few inches away from that, you see on the shiny metal, it only shows a temperature of 74.3 degrees Fahrenheit. So why such a big difference? Well, of course, the can's at the same temperature, 3 inches from where the electrical tape is. But again, it's emissivity. The shiny metal has a very low emissivity, where the electric tape has a high emissivity and is telling more of the truth about what the actual temperature is. And here's a chart that shows just a few different types of materials and what those emissivities are defined at. And you can see that copper, of course, is what we're looking at with transmission line, has a very, very low emissivity if it's brand new and polished. But if it's oxidized and it's been on the tower for a while, it's got a higher emissivity. You can see other objects here that are fully defined in terms of what the emissivity values are. And generally, you can plug these emissivity values into the type of camera you're using, and it compensates for the fact that the emissivities are not 1.0. And it'll give you a much better temperature reading. Well, we're here to talk about the applications for SUAS, or small unmanned aircraft systems, in broadcast engineering. And to do that, I want to talk about qualitative versus quantitative thermography. Qualitative, as you might guess, is using the thermography skills and training of somebody to evaluate the thermal images very carefully, kind of like a radiologist would read an X-ray. So you need some special skill sets to make sure that you're reading these thermal images properly and not getting fooled by labels on the image, which might have a drastically different emissivity than the copper, and might look like you have a problem when you really don't. Quantitative thermography involves looking at the numbers. So let's say you're in a controlled environment indoors, and you're able to get accurate measurements Making sure that you take those pictures properly and getting the accurate measurements is part of quantitative thermography skills. Such examples of quantitative include motors, electric panels, and human subjects. Qualitative would include solar arrays on rooftops and broadcast transmission lines and antennas that are located outdoors and not in a controlled environment. So how do these cameras work? Well, there are all different types of infrared cameras, and basically we're looking at electromagnetic radiation. And when the IR energy, this radiation, strikes the detector, it heats up and it changes the electrical resistance in the chip, which is the CCD sensor. And those changes in resistances are measured by a microprocessor, A to D converters, and so forth, and processed into digital signals that actually create the image on the display that you're seeing on the right-hand side of the screen. Generally, there are different types of sensor chips. Vanadium oxide is one of the more popular, but amorphous silicon resistors are also used in different types. There are also much more exotic and expensive types that get into the hundreds of thousands of dollars that are used for very specialized applications. So for what do we use the drones for in broadcast engineering? Well, visual tower inspections, of course, infrared scans for heating, which is what I'm talking about here this evening. Many companies have started to do RF signal measurements with drones, which can be much more efficient than hiring a helicopter or ground-based measurements. And of course, thermal imaging of AC power panels inside, which don't necessarily need to be used with a drone if they're inside. So why are we doing this? Well, it's a brand new technology, and it's proven useful already because it gives us kind of a sixth sense of what's occurring in and around our electrical and RF systems. We can't see infrared energy, but we can certainly detect it with the new technology we have, especially when you combine it with aircraft. Infrared imaging allows us to detect that radiation that's readily visible in a traditional photograph, or that it's not, I should say, visible in a photograph. So a RGB visual photograph is, of course, not going to show you any of the heating, but infrared, of course, can bring that out. So the applications include tower transmission lines, the broadcast antennas mounted on the tower, and then indoor, we've had some success with RF patch panels, understanding why they're heating and how they're heating. RF combiner modules, same thing, RF motorized switches, and of course, what's been understood for many years, using it to look at electrical and AC power panels. So I've been using this term SUAS. What is an SUAS? So the official definition by the Federal Aviation Administration is a small unmanned aircraft system consisting of an unmanned aircraft. It's got to weigh less than 55 pounds to be considered a SUAS. It includes the aerial vehicle and the system on the ground connecting the operator to the UAV. So it also is basically the joystick remote controller that controls the aircraft, as well as the operator on the ground is part of the system. So there's really three parts to it. And so, you know, these aircraft have several advantages. One of them, of course, is it allows us to inspect areas on the tower that are not easily accessible. They're safer and less expensive than a tower crew. They have the ability to fly in a wide range of weather conditions and generally can be deployed with very little notice, allowing views from not only around the tower, but also above the tower looking down, which is something obviously that a tower crew is not able to do. So it's not all sunshine and fun and games. There are a lot of different considerations and practical considerations when considering operating a drone. First of all, it requires for commercial operations, a Part 107 FAA licensed pilot to operate the drone. So that's a commercial license. It's not hard to get, but there is a procedure and a test you have to go through to prove that you know all the FAA rules and regulations, so that you're not doing anything unsafe or interfering with other aircraft. Generally requires a second person as a qualified spotter. The person running the aircraft is looking at basically taking the pictures and operating and manipulating the controls. But one person really needs to, as FAA rules point out, be constantly in visual touch with the aircraft. It also most often requires, and it depends on where you are geographically, FAA and local approvals to fly, and especially above 400 feet above ground level or above the top of the tower. Other considerations are insurance for liability and the hull insurance as well. The aircrafts tend to get into a lot of money, and so do the payloads that they carry. Other considerations are environmental conditions requiring wind speeds within tolerance, and that varies with the equipment and also the experience of the pilot. And of course requires ceiling and visibility clearances because you've got to maintain visual contact with the aircraft at all times. One of the other things to consider is that when you're flying and trying to get these thermal images, you want to fly at dusk or dawn when the sun is definitely a few degrees at least below the horizon, but generally not so late that you can't really see the tower. So there should be some twilight there to allow you to fly safely, but you don't want the sun beating down on the antenna or the transmission line, because that would decrease your signal to noise. You're looking for, in some cases, subtle but significant temperature differences, and that's harder to get if you think about it when you're getting a lot of solar heating. Another good time to fly, but not as good as dusk and dawn, would be on a bright overcast day where there wouldn't be any direct solar radiation hitting the targets that you're trying to measure. And of course, the flight should take place when all the stations are operational on the system, so that you can actually see what effect they're having on the heating. So one question I get a lot is, Paul, you fly these drones pretty darn close to a lot of high RF sources. Aren't you worried about the drone losing contact with the controller and doing something kind of strange? And the answer is yes, but we take some precautions there. We use something called RTK technology whenever possible, which is our friend. RTK means real-time kinematic positioning. And I'm going to show the next slide that demonstrates a little bit about what that technology is about. But we also try and fly as far away from the radiating elements as possible, but still close enough to get the useful spatial resolution that we need to tell if there's anything going on there. And part of that comes with choosing an appropriate focal length lens for the camera and using, of course, caution for guy wires and other obstacles around the tower. And we never fly over people or animals. So I mentioned RTK in the last slide, real-time kinematic positioning, and that is a satellite navigation technique used to help us enhance the precision of the positioning of the aircraft. But it also does some other things, like it takes the magnetic compass off the aircraft and relocates it to a ground base station, which would not be subject to the interference from electromagnetic radiation from the broadcaster. And it has GPS positioning correction information that's obtained from a number of the satellite systems that you see listed here on this slide. And the picture here shows the operator communicating directly with the drone, but also the RTK base station communicating with the drone as well, giving those corrections to the aircraft. So some of the benefits of using this external base station include pinpoint accuracy, and I'm talking about accuracy to within 1 centimeter of positioning. Now that doesn't mean the drone will stay within one position of 1 centimeter of where you put it, but the actual information that you're getting is potentially accurate to that kind of tolerance. It also gives you less concern about winds because the control is better. As I mentioned, it brings the electronic compass away from the aircraft and RF sources. And you actually always know the exact position of the drone. And it gives you accurate hovering and positive control in gusty conditions. This is what it looks like. It's mounted on a surveyor's tripod. And not very big, and generally we locate this within a few hundred feet of the launch deck. And as long as it has visual contact with the controller and the drone, you're in good shape. So one of the main things that really surprised me when I started learning a little more about this was some of the challenges and limitations of operating outside in an uncontrolled environment. And one of my big disappointments was I found out it was pretty much meaningless to specify or compare precise temperatures. I thought it would be great to fly up a transmission line and get all these precise temperatures, log them, and then come back a year later and compare them to what I measured. And unfortunately, that's not terribly practical, although I'm working on some ways around that. But basically, what the problem is wind, and a 3-mile-an-hour wind can cut the temperature reading in half. And you really don't know what the wind is at every single altitude you're measuring. So it kind of negates the value of all these precise temperatures that you can look at with the drone. You can get relative temperatures easy enough, but precise temperatures that you can compare to going back a year from now, or going ahead a year and going back a year, just not gonna work. Not to say that this is not worth it, because I will show you in some subsequent slides here how valuable this kind of technology is. But I just wanted to make it a point that this quantitative analysis is not quite possible quite yet, until we have more information about real-time winds. The angle of the image acquisition is also critical and requires more than a 60-degree angle to get a good reading. And the emissivity of different components will produce different indications on the photograph. So like I was saying before, it's important to identify the labels and other surfaces that you can see with a visual photograph to avoid the misinterpreting of the data. And that's why we do these visual photographs as well as the infrared. Spot size ratio is the ratio of the distance from the camera to the target. And this is something we have to calculate every time we go and do one of these surveys. There are different lenses for the infrared cameras that can be loaded as payloads on drones. Unfortunately, all the ones I know of are not interchangeable lenses, so that once you purchase a infrared camera, you're kind of stuck with that lens. And the infrared cameras are very expensive. So it's important to define the kind of mission that you're going to be using the camera for and get a lens that's appropriate for that. As you can see in this chart, there are 4 lenses that are available for the DJI drone that I use. And I've chosen the 19mm one, which is fairly telephoto. And that allows me to stay a little bit further away from the object that I'm looking at, in this case, transmission lines and radiating antennas. But on the other hand, if I was trying to photograph a large solar array or something like a rooftop, 19mm probably wouldn't be the best choice, because it would be focusing on just one small area. So the spot size ratio is something you go through and do the calculation and make sure that when you fly the mission, you're at the appropriate distance with the appropriate lens to get the appropriate resolution that you need to make determinations. So this is a photograph of one of the drones that I was using. I just changed, but this was the one I used for the last year or so, DJI Matrice 210 RTK. This one you can see has two payloads on it. The camera on the right side of the drone is the infrared, and the camera on the left is a high optical zoom camera that can do the RGB photographs. You can run this with one or two payloads or no payloads. You can just use it with the camera that's built into the drone to take pictures of the target that you're looking for. This particular unit has two batteries and can stay in the air for about 40 minutes under ideal conditions. And I just changed to the newer technology. This is the Matrice 300 RTK. It's shown without any payloads here, but it can actually take 3 payloads.
Check one.
Yep, I can hear you. I can actually take 3 payloads, a visual camera, infrared camera, and on the top, you can actually put a new accessory called millimeter radar, which is a circular radar that can actually detect very small objects for collision avoidance, such as guy wires. So this newer one has a lot of advantages over the 210 RTK. This one actually has dual batteries as well, dual GPS, and a lot of redundant systems, and can actually stay in the air for a maximum of about 50 minutes, even though I wouldn't go any more than 35 to 40 minutes with the payloads, just for an added margin of safety. But the technology is coming along quite nicely. This is the camera I use for the infrared imaging. It's called a FLIR XT2 camera, and they've teamed up with DJI to make it compatible with the gimbal and the drone itself. 640 by 480 resolution. Doesn't sound like that high resolution, but you really don't need it for this kind of application. It can also take sequence files, which are basically videos, infrared videos at 30 frames per second. So that's very handy because you can fly up the tower at a known vertical ascent rate and just let it take pictures, and you can extract individual frames for examination in the post-processing process. And what it does is it takes radiometric images. If you haven't heard of what a radiometric image is, it's basically just a JPEG image, but it's got metadata attached to every pixel that indicates the temperature value. So you can see the value in this for post-processing, where you have a radiometric image and you can go ahead and look at every single pixel and get a temperature value from it. And this, of course, allows for great quantitative evaluation of the scene during post-processing using software like FLIR tools, for example. This is an example of the Zenmuse Z30 camera, Z30. It is a RGB camera with 640 by 480 resolution, not great resolution, but look at the optical zoom on it. It's 30 times optical zoom with 6 times digital zoom and only a 2.13 megapixel sensor. Doesn't look all that impressive, but when you combine it with a aircraft and you look at the optical zoom, it can produce some remarkable detailed images. And this is the latest camera I'm using with the drone I now have, which is the 300. It's called the H20 camera, and they do make a model of this that does infrared imaging, but I prefer to use separate cameras for RGB and infrared. This one has high resolution, very high optical zoom, and a digital zoom all the way up to 200 times. And you can see it's got a much higher resolution sensor, a 20 megapixel sensor, and is water rated at IP44. And it also includes a wide camera and lasers. So this is a pretty amazing payload here. It does a lot. And I've just started to use it and have been pretty impressed so far. This is an example of what the controllers look like. There's the display on the left, and the controller on the right, they all use they all use the same batteries, but discrete batteries. So you can change them out quickly. And the runtime on these is quite long. The display is great for outdoor use, and it's a touch screen, so you can manipulate the controls by the touch screen as well. And this is kind of what it looks like when I do the flying. This is the flight deck when we put down cones. You can see the base station on the right. We mark off the landing area, make sure that all the area is clear. We use hard hats, safety vests for increased visibility. We always have emergency phone numbers handy and a first aid kit. These drones are very reliable and very safe, but they can also hurt you. Those propellers are moving pretty darn quick with a lot of torque. So we don't take any chances and basically make sure that we're all staying safe when we do these type of operations. So here's a couple of examples of some images. This is a cellular array at about 150 feet above the ground. You can see, where the yellow light image is here, and those are, of course, the electronics, not the antennas. The antennas are not heating up here, but the electronics, the amplifiers, and so forth are showing yellow because they're higher than the ambient temperature. I like this kind of picture. This is showing an ice bridge connecting to the base of a tower. You can see the transmission line clearly shows up here as being warmer than the ambient temperature. And if you look kind of toward the lower right-hand portion, you see a telephone pole transformer, and that sticks out like a sore thumb because it is producing some heat and is not as cool as the environment. And this is one of my favorite slides to show because I was able to actually help some broadcasters figure out what was going on. This is I believe it's an 8-inch transmission line. Yeah, I think it's 8-inch transmission line. And it is one of two that feeds a UHF antenna that serves as a broadcast antenna for about five TV stations. And they were experiencing VSWR trips on an irregular basis, like maybe once every 3 or 4 weeks. And they brought in a spectrum analyzer and they brought in a TDR, and they had some guys open it up and look at it, the transmission line from the base. And yeah, they could see the flanges and they saw a few little things, but nothing really that would point out any kind of problems. But it went on for several months, and they'd get these quick VSWR hits and then everything would be fine. So they asked me to come in and take a look at it with the drone. And the picture on the left here is an infrared image on quite a humid, kind of not great night. And you can see the transmission line in that picture clearly has a hot spot. And I was all excited to see that because I thought it meant something. But I know that these pictures can be deceiving. It could be a reflection, could be a label. So I went back and carefully looked at the RGB photographs, came back the next night and imaged it again. And sure enough, from a different angle, I saw the exact same kind of heating going on. So I gave the report to the broadcasters, and they hired a tower crew to come up, take a look at exactly where this was. So I told them the exact height above ground. They pulled it apart, and this is what they found. There was in fact burning going on, and there is a O-ring that was not seated properly that had fallen out of place with vibrations over time, and had apparently landed on the Teflon insulator and started some burning. They had to actually replace about 150 feet of that hard line. But I like showing this slide because it's a good example of where infrared can really help you figure out if there's anything going on in your tower, and if there is, exactly where that is. This is the same problem that got diagnosed with the infrared, and it demonstrates different color palettes. And this is all stuff you can do with the radiometric image, afterwards in post-processing. So different color palettes can help to identify different areas of uneven heating. And this slide is just showing how different you can make these look using these different palettes. And there are about half a dozen, maybe a dozen different palettes that come standard, and some are industry standard, and some are not. And you can mess around with the colors to bring out these different anomalies that you can see with thermal heating. So almost everything can be adjusted and compensated for in software in the post-processing. And that's one of the great things about thermal imaging. And I say almost because there are a few things that cannot. And we call that forward: focus, range, and distance. And this means that the picture must be in focus. You can't really make a picture in focus if it's not in focus after the fact. It must be taken in the temperature range that's correct for the type of hardware you have. So in other words, you can't be looking at 1,000-degree temperature if your camera can only detect 400 degrees temperatures. You must be close enough to the target to evaluate it. So that comes back to the spot size ratio I was talking about before. So all these things are basically necessary to make sure that while you're in the field, you get these parameters correctly, and then pretty much everything else you can correct for in post-processing. And I mentioned focus. Focus can be degraded by flying too high or too fast, or if you're yawing the camera too much, too quickly, you're going to blur the picture. If the gimbal is not working right, it can lead to blurry pictures, as well as excess humidity. Whoops. Sometimes there's a delay here. There we go. So stretching the image is the other thing that can be done nicely in post-processing. We call this the span, and it allows us to ignore thermal ranges that aren't relevant. So when you're taking a picture of a tower, part of the picture is going to be the sky, and the sky is going to be a lot colder than the tower or the transmission line. And that's going to, by default, extend the dynamic range of what you're looking at. And that corresponds to the left-hand picture here that shows no stretch. And you can see it's very hard to identify the transmission line, much less the area that is a problem on the transmission line. So by manipulating the span in software, we can only look at the temperature range that we're interested in the target. And we can basically ignore the rest of the dynamic range that we're not interested in. And that's shown here on the right-hand side of the picture. And this is all by manipulating the sliders in the software. This is very, very similar to the kind of things that I would be doing with astronomy pictures because of the dynamic range of the CCDs used in imaging deep sky objects. We're only interested in a certain small range that you might pick up there. So I talked about the different kinds of images you can get. Took this last week in Florida. This is top down, looking at a candelabra antenna there. One of the things that I like to do is to fly up to the area where the antenna is and stop below the antenna, so I'm not really close. And then I will zigzag out, so that I can go higher and above the candelabra tower or whatever kind of tower it is that I'm imaging, but be further out, a greater radius from the antenna so that I'm not right in the beam. And then I can use the zoom features of the camera to image from above or from further away. Here's an example of looking at a UHF TV antenna. There's the visual picture on the left and the infrared picture on the right. A little hard to see in this picture, but you can see some yellow areas there that are behind the radomes that indicate where the power dividers are. And the nice part about this is you can see if there's anything strange or uneven about this, and you can compare the blueprints from the manufacturer.
Really good presentation. Oh, sorry.
I'm sorry. Did I need to stop for some reason?
No, I unmuted for a second, just saying how good this presentation was. I apologize.
Oh, okay. Sorry about that. No problem. I'll continue here. Yeah, so you can look at the power dividers behind the radomes and actually see what's going on. And like I was saying, compare that to the blueprints from the manufacturer and see if they agree with the heat signatures that you're seeing. Here's an example of a handheld camera that I was using indoors. This is a piece of 8-inch vertical transmission line, and you can see indoors where it's a controlled environment, we can actually measure the real-time temperatures, the exact temperatures, by calculating the emissivity and plugging that into the camera. And you can see some of the Teflon insulators here show up as hotter temperatures than other parts of the line. You can also see the purple areas of the transmission line, which indicate reflections and different types of indicators on the camera that don't really indicate necessarily different temperatures, but different reflections. So that's one of the reasons why it's a good idea to move around the transmission line and get it from different angles. As I mentioned before, the best times to shoot are just after sunset. The advantages are the FAA considers that still daytime rules, and it's also safe to visually see the tower and maintain the clearances without getting the solar loading problems. A couple of pictures I wanted to show you here of some of the RGB images. I like all these, but the one on the left is kind of interesting. It's the top beacon on a 500-foot tower. And you can see with the stabilization of the gimbal and the zoom capabilities, you can actually get in close enough to read the barcode on the beacon. So you can really see if there's anything that's deteriorated on the tower. The picture on the right is a guy wire attachment point, and you can clearly see that the cotter pin is in there and hasn't deteriorated. A couple more quick pictures here. One on the left is the picture of the attachment of a pole on top of a tower. You can actually get in real close, like I'm showing on the right-hand side, to see that that bolt is still tight and snug down. I don't mean to say that any of this replaces an inspection by a human being, but it sure is great to be able to look at this stuff. And if you do see any problems, you can point them out to the tower climbers before they get up there, save them time, and possibly making it a little bit more safe for them to do the climbing. Here's another 1,000-foot tower. This is in Boston. You can see that we discovered some of the stuff was attached by electrical tape, which the tower owner was not too happy about. So, we made sure that they went up there and corrected that kind of thing. These are things that the tower owner would never see without, without a close inspection. Visual tower scan. This, I just wanted to show a quick video of an example of how stable the gimbals are when you're doing one of these sequence films going up the tower. And I will show you, let's see, at 3 minutes and about 50 seconds. This is kind of routine here, but if we go up to this point here, you can see this is the taper in the tower. And I wanted to show this because right coming into view now is a FM antenna. It's an ERI wraparound cogwheel antenna. And right above this antenna, I'll stop this and show you a little better picture of where that heating was in the example that I showed you before. And I'm going to stop that right about here. And you can see right above the white flange here is the transmission line. And this is the area where the heating occurred in the previous slides that I was showing you. And I'll do a little better than that. As we can show you the same thing here in terms of a radiometric infrared sequence file here. So this is basically a video at 30 frames per second where we're showing you the entire thing in infrared. Now this can be post-processed, and it was post-processed to bring out the transmission line and ignore the sky in the blue that you see in the background. So we've kind of taken the dynamic range and made it more where we're interested in. I think if I go to this part here at about 45 seconds, you can see that area where the taper in the tower is. And we're looking at the FM wraparound antenna here with its screens. And just in a few seconds, right above there, you're going to see the problem, which should be coming into view just in a second here. And there it is right there coming down from the top of the screen. You see that bright yellow area is what I showed before. And that is where the transmission line was heating because of the problem with the O-ring. The other areas of interest here were, I think, in about 3 minutes, where we can show you the top of the tower. So here we're getting to about the 1,100 foot part. You see a small TV antenna moving through. And I'll just let this run for a few seconds because we'll come up to the top of the tower where the pole mounted antenna is. This is a side mount antenna you're seeing right now, but you can actually see from a little bit different angle the heating signature of the UHF TV antenna, which is coming into view right now at the top. This is a two-part antenna. It's got a lower and an upper half, and you'll see that basically right there where you see the division between the upper and the lower. So if you take a close look at this, I think I can pause it here. You can certainly see where the heat signatures are and the power dividers are. We didn't find any problems with this antenna, but it sure was good to be able to take a look at this and get it over to the manufacturer and compare it to the blueprints and see what we're up against there. So we're about an hour here. So I wanted to conclude and let you know that drones can be used to perform these inspections and broadcast towers. Proper certification and piloting of the drone is required by an FCC, an FAA rather, Part 107 licensed pilot. Authorizations are required, and interpreting the images really is a bit tricky. So it requires an understanding of how the heating occurs and how it's displayed on the cameras and in the software. Of course, drones can also provide a unique platform for RF signal measurements. And like I said before, utilizing drones for intermediate tower inspections will enhance safety and lower inspection costs. Here are some resources. You can contact me here at schulinsolutions.com. I'm happy to talk to anybody about this technology. Infrared training is a good place to get some training if you're interested in getting a thermography certification. You can go to infraredtraining.com or infraspection.com. FLIR Tools software is free for their basic software package. You can get that at FLIR.com. Even if you have an inexpensive camera that you use with your cell phone, those radiometric images are compatible industry standard, and you should be able to manipulate them with the free software. And of course, on YouTube, there's tons of great resources for free training, especially from ITC and FLIR. So I would encourage you to take a look at that if you're at all interested. And I'd also like to thank FLIR. Bill Schwann was my instructor for thermography, the Infrared Training Center, Florida Drone Supply, Jim Stenberg from American Tower Corporation. I've worked closely with Gary and Cindy Cavell from Cavell Mertz, who have been very supportive, and my friend Jim Leifer from American Tower Corporation. So thanks to all of them. And I want to thank everybody here for their time as well. There's my phone number up there. If I can help anybody else at all, I'd again be happy to do that. And I know we're at about an hour, but I'm happy to stick around for a few minutes and take any questions. So I'll conclude with that. Thank you.
Awesome. Well, thanks, Paul. It was really informative and really thorough. Really appreciate it. Going to the chat, I saw a few questions here. Jim, I know you had a few. One was, can drones be utilized to look for lightning, grounding, and bonding problems?
Well, I don't know about lightning problems, but certainly grounding and grounding and bonding problems from a visual standpoint, yes. From an infrared standpoint, there'd have to be some heating occurring, and sometimes there is current flowing if you've got a bad ground. I've never used it for that before, but I certainly wouldn't rule it out. Good question.
Mr. Shullins, in my experience on CTO Gray, we had a lot of aging infrastructure taking in. We saw a lot of problems. I'm sure there's with effectively, if you guys ever need a good lightning guy, Homer Uten out of the lightning capital of the world, Tallahassee, Florida, is renowned. He's inspected hundreds and hundreds, and it'd be interesting to have you two gentlemen discuss, because of his use of grounding meters. And as you know, the coefficient effect, there's a trade-off. And I was just mesmerized by your whole presentation. I hope I speak for others, and I'm speaking on behalf of our tour. And we're really, I know a Gray station that went off the air, and there's no reason they should have gone off the air, brand new digital build, because they didn't, like you said at the beginning, this is technology. And it even encouraged me to work with the SBE or to try to get a certification program going for SBE, so we can do everything from the FAA rules to the thermal, all of it. And finally, they're going to need someone like you. The interpretation of the data are very important. Are you logging these recordings so you said later you can do comparative analysis? And one more question, LTE MIMO, can you multiple carrier, is that help, or do you need a couple of drones or a drone swarm to do multiple carriers for, let's say, a MIMO type of operation?
Well, no, thanks for those questions. I appreciate those kind words as well. We found a lot of, especially with the TV repack, a lot of infant mortality. So this has been extremely helpful in, identifying some of those problems. In fact, the one I identified here in this presentation was a repack situation. So the technology is really good. Regarding, you said, can you repeat the last part?
Yeah, sure. I threw three at you, and I don't want to take up the meeting. These are the questions I just had going. As far as the grounding and lightning side of it is a huge issue I see with lots of sites, especially studio buildings, because of legacy technology wasn't removed. As you know, they're outside conductors, and as you know, current flows wherever it wants to flow. And with a combination of this, could there be, what I see here for is a big justification. When we do grounding inspections, let's get the drones involved, is what I'm trying to say. It's better justification, I think. And also, I had a thing earlier about transmission line. You mentioned use a piece of tape or something, to calibrate. Could maybe we encourage, would it be at all helpful to try out, have MIOT or whoever, transmission line makers put a calibration point somewhere on the line, and that way. Yeah. I'm sorry.
Yeah,
that would increase manufacturing costs.
No, absolutely. That would be something that could be done after the fact too. It just needs to be, really, it's as simple as electric tape, because we know the emissivity of the electric tape. So that would work well too. So grounding is something I haven't really thought about, but I think that's a good point. And, if there's current flowing, there's two aspects of helping with grounding problems. One would be the physical inspection, which can be, the visual inspection, which could be augmented by a drone. And the other is electrical. If there's heating occurring, again, where it shouldn't be, the drone should be able to help out with that. I think the third question you had related to RF signal measurements, if I'm not mistaken. Well, you're on mute.
Yes. So I've been experimenting with ENG, broadcast auxiliary services, MO, MANET, mesh, all these technologies, as you guys may know, it's not one antenna, it's two or three or sometimes four antennas when you're doing heat mapping, this you're dealing, it's not the same as like a contour grade B. And I'm finding that those tool sets, especially if you're dealing with interference and you think you have interference somewhere, we're getting maybe a little off topic, but I'm just trying to see what the full suite, you know, of capabilities that you could provide for, especially as we look at the.
Yeah, no, I appreciate that. And I'm happy to talk to you offline. I don't want to purport that I am an RF signal measuring expert, because I'm not. But I know some people that are, and I
Might
know
have a couple on this call.
Yeah, and I know that you know, the drones are very useful for that kind of thing, and you need to have the right equipment and so forth. But from a thermal standpoint, sure. I mean, we can detect electromagnetic radiation in the infrared range that would you know, indicate problems with any type of antenna. So you know, I hope that's kind of an answer for that third part of your question. If it relates more toward RF signal measurements, I'd refer to you to an expert on that.
Yeah, Paul, I think I got one last question here. You know, I don't think we talked much about like looking for leaks, you know, in transmission line, things like that. Have you used this technology for that at all?
No, I haven't, and I don't know how well it would work for that. But you know, another part of what I do is this monitoring stuff, and I'd encourage anybody that's kind of concerned with leak detection to talk to me about the Stellar Eclipse product, because you know, we measure flow rate and we measure gas pressure, and we do some pretty interesting things with the software to look for trends, and not just, okay, the pressure is at 2 pounds when it should be at 7 pounds. So with the software, we're able to anticipate what's going to happen by what's not normal. But when it comes to infrared and looking for leaks with infrared, that's not something I've gotten into, but not to say maybe it wouldn't be useful in the future. I need to experiment more about that.
I got one more. Have you done any high altitude stuff, like really like above, let's say 10,000 AMSL, you know, that kind of stuff? Because people know that we burned up transmission lines. Sometimes you get the low pressure system comes in, raises the apparent effect, the altitude, the rating, if you will. And I've also found that there are some operations that are different from a walk-up guy wire to a high altitude location. Does that factor?
Never done anything more than 400 feet above the tower. So I wouldn't be able to answer that question, but I would love to have a conversation with you about that, because I don't have a lot of that understanding. But certainly the hardware is, you know, is capable of higher altitudes if you get the right FAA clearances and so forth. So love to connect with you.
I don't mean so much the airframe. I mean more on the science.
Yeah.
You know.
Yeah.
So.
Yeah,
Okay.
no, I don't have any experience with that, honestly, but would love to continue that conversation offline.
Awesome presentation, Matt. I hope I speak for others. I'll shut up. I really blown away.
Any other questions for Paul before we get going? And then obviously your contact info is there, so give him a call offline as well. Anything else? All right. Well, thank you again, Paul. Great presentation. Really appreciate the time. Next month, we will have our April, what are we in? May meeting. It's going to be a lunchtime meeting, 11:30. It's going to be on the Zoom again. We have Jeff Schick presenting, so we'll send out an email about that as it gets closer. That is next month. Unless we have anything else, I'll say goodbye. Have a good month, and we'll talk soon.
Bye, everybody. Thank you.
All right. Thank you. Thanks, Marcos.